Hello everyone and welcome to my CompTIA A+ 1101 video series. In this video, I will review the concept of software-defined networking, its benefits, and how it is changing the way that networks are designed, managed, and operated. While it is included in Objective 2.2, it isn't hardware, so I felt like it deserved its own video. Software-defined networking is essentially setting up a network virtually without the physical hardware that most people are used to. Let's get started by taking a look at a very simple network layout. The network includes two routers, with one connecting to the internet, and four switches that are responsible for managing all network traffic. Also, other hardware such as access points, load balancers, firewalls, and various network appliances are used but not shown. Scaling the network is easily achieved by incorporating more routers, switches, and other network devices. However, configuring these devices grows increasingly more difficult as the network expands. This is because routers play a huge role in intra-network communications by taking incoming data packets, reading the destination address, and then forwarding those packets to the next network to bring the data closer to its delivery. This functionality is enabled by two key aspects of routers: the physical connections and the circuitry that facilitates routing, and the logical routing table, which is a database used to decide where the packets should be sent. In traditional networking, each router is responsible for maintaining its own routing table. Almost all routers have the ability to talk to other routers for routing updates. The entire setup can be difficult for admins to manage, so this doesn't even include troubleshooting or other types of downtime. This is where software-defined networking comes in. The goal of SDN is to make networks more flexible and efficient. This is accomplished through three layers: the application layer, which is responsible for management tasks, the control layer, or aka the SDN Controller, and the infrastructure layer, which is the forwarding layer. In the application layer, SDN management operations take place using methods like SSH, SNMP, or an API. The control layer, operated by one or more devices, determines packet routing and makes logical decisions. Last, the infrastructure layer handles the actual forwarding of the networking packets. In this setup, physical devices execute packet forwarding based on the instructions received by the control layer. The SDN software provides centralized network monitoring by allowing all devices to be monitored in one application, instead of using separate monitoring apps for each piece of network hardware. The SDN controller serves as an abstraction layer where applications connect to interact with the network, giving the impression of direct communication with the networking hardware. As long as the data is successfully transferred from one point to another, the exact details of how it occurs is not important. Thanks to this abstraction layer, the fundamental network hardware and the configuration can change without affecting the application's performance. In a virtual network setup, there is no need for physical hardware, as the communication between servers is enabled through logical connections. For example, multiple servers running on the cloud can share the same hardware but communicate effectively using logical NICs for data transmission. In a traditional setup, having multiple servers with the same MAC address would be problematic, but software-defined networking resolves this by assigning each server a unique logical NIC for seamless communication. This approach ensures smooth data exchange between servers without any communication issues. Software-defined networking is an approach to networking that separates the control plane from the data plane in network devices. This separation allows for centralized control of the network, which can be programmed, enabling configuration and management through software applications. SDN's focus is to make networks more flexible, scalable, and easier to manage by breaking down the network's intelligence, the control layer, from the physical infrastructure, the data forwarding layer, and then enabling automation and dynamic supply of network resources. Alright guys, so that wraps up Objective 2.2 for software-defined networking. Don't forget, I have all of the questions for this content linked below. If you have any questions or comments, or if you need help with anything, go ahead and leave the comment down below and I'll do my best to answer that for you. I'll see you all in the next objective.